All right, it's 5 past the hour, so I think it's a good time to get started. So just a reminder to everyone that we are recording this so that people who are unable to attend today can view it later. The breakout rooms will not be recorded. All right. Remember to keep your mic on mute when you're not speaking. All right, so welcome. So my name is Paul Yip. I will be the host today, and welcome to the U of T Department of Lab Medicine and Pathobiology Core Lab Quality Turning Indicators into Action workshop. And I'll be your host today, and I will start off with a land acknowledgement. So we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. So on behalf of the Quality Indicators Task Force, I'd like to acknowledge the support of the Department of the Laboratory Medicine and Pathobiology. Our chair, Rita Kendall, who reimagined the structure of LMP in her first term as chair and recent successful departmental review, and also the support of Professor Costa Rodelli, Vice Chair of Quality, who initiated the Quality Council. My thanks to the administrative staff of LMP, who have supported the council immensely, and in particular, Jenny Bozak, who is doing all the communication support for today's workshop. A year ago, the Quality Indicators Task Force held its first workshop, and since then, several working groups have produced numerous resources and recommendations. These are all available on the LMP website. The Core Lab Quality Indicators Working Group, shown here, represents 9 Greater Toronto Area hospitals, and we have put together today's workshop. We are very proud, and these representatives here also cover the U of T affiliated teaching hospitals, and I am grateful for their collaboration. Many of the Quality Council projects are led by clinical chemists, but these are of broad interest to the lab medicine community, including pathologists, lab leaders, and technical staff. Nonetheless, the CSCC has accredited this meeting for continuing education credits, and this is possible by the generous financial support of the OSCC for the accreditation. So here's the agenda for today. We have 3 speakers. We have Dr. Lusia Sepiashvili, Dr. Davor Brinc, and Dr. Saranya Arnoldo. It promises to be informative and interactive. So please submit your questions and comments into the chat box. And at the end of each speaker, we will have some time for questions and answers. In the 2 main talks, turning point for turnaround time, and also bench to bedside, the hemolysis indicator, we will have a breakout room discussion. And then we will conclude by 11 a.m. And so without further ado, let's go to our first speaker. Dr. Lusia Sepiashvili, she is a clinical biochemist in the Department of Pediatric Laboratory Medicine at the Hospital for Sick Children, and she is also an investigator at the Sick Kids Research Institute. And I'm going to turn it over to you to give us our introduction to Core Lab Quality Indicators.
Thank you, Paul. And first, I just want to confirm if you can see my slide, okay? Thank you for the introduction, Paul, and thank you everyone for joining. I'll be giving a very brief introduction to Core Lab Quality Indicators. So first, I have no conflict of interest to declare, and there are 2 learning objectives for this presentation. First is to state the current local, national, and international initiatives for harmonizing quality indicators, and then being able to identify key quality indicators and their reporting recommendations. Specifically, I'll be talking about the IFCC model of quality indicators, which is the international initiative, and I'll be mentioning the SQVC platform, which we would be discussed in much more detail later as a national initiative, and then the work of the LMP Quality Council efforts to harmonize core lab quality indicators across the Greater Toronto Area. And then I'll also mention the key quality indicators proposed by the QI Core Lab working group, and how to do the math in particular and report them for continuous monitoring. So as many of you know, quality indicators allow labs to quantify the quality of lab processes, which is fundamental to patient safety and has been shown to be associated with improved patient outcomes. However, it's been recognized that there's a large amount of heterogeneity in how labs report and monitor the quality indicators. Therefore, it's been recognized that harmonization of quality indicators is necessary to ensure that all clinical labs have defined quality standards, and they have defined ways to report and benchmark these quality standards in a manner that is consistent. The identification of reliable quality indicators across the total testing process represents a crucial step in enabling users to quantify the quality of lab services. And many of you may be familiar with this figure. You can see the various steps in the total examination process. So the use of quality indicators allows us to assess and monitor the quality system in the lab, and this can be extremely valuable in keeping the total testing process under control in a systematic and transparent way. So that includes our pre-analytical process, a post-analytic steps, as well as monitoring analytical errors. Through this system, this encourages investigations and error detection and leads to identification of strategies and procedures for further or continuous improvement. So in order to promote the use of harmonized quality indicators and reduce errors in lab testing, the International Federation of Clinical Chemistry has come together with a working group on lab errors and patient safety and developed a project on quality indicators. And they've noted that the different experiences worldwide in the use of quality indicators have made it difficult to establish a reliable state-of-the-art comparator, and the various data sets that are reported by many labs are not comparable. So they recognized this gap and noted that standardization is needed. Therefore, after many years in the making, they've defined a roadmap for harmonizing quality indicators in lab medicine through a consensus statement, which you can find through these references here or on the IFCC website. And they had an objective to design a routine, formal, and proactive system for monitoring that uses validated measures that focus on lab performance, that creates a common reporting system through standardized data collection and defining state-of-the-art, as well as quality specifications for each QI. And it was important that this is accomplished and that clinical labs are able to execute or follow this roadmap independently of the size of their organization or the types of the activities, the complexity of the process, or the different degrees of knowledge and abilities of the lab staff. So this should enable reliable comparison of data collected from different labs and achieving effective benchmarking with the IFCC having the goal of doing benchmarking at the international level, and then subsequently being able to develop standardized procedures and recommendations to manage various critical processes. So they had the FCC define some prerequisites for quality indicators as well as requirements for quality indicators. So in terms of prerequisites, as I mentioned, these QIs should be applicable to a wide range of labs. They should be scientifically robust with a focus on quality, and they should be have defined evidence-based thresholds for acceptable performance, and they should allow the use of timeliness to measure lab improvements. Sorry, my slides are moving for some reason. And then in terms of requirements, a quality indicator should be patient-centered to promote total quality and patient safety. As I mentioned, also cover the total testing process and be consistent with ISO 15189, which stipulates the need for clinical labs to use quality indicators, although it doesn't specify the exact quality indicators that are mandatory to be monitored by labs. So in this IFCC model, that focus on the quality of service and possible effects on patient safety, they also considered the feasibility of data collection and created this new model of quality indicators after a consensus conference in 2016. And they included 53 measurements to monitor 27 quality indicators. And they have assigned these a priority index. So you can see 1 is mandatory, 2 important, 3 suggested, and 4 valued. And the quality indicator categories have been divided into key processes, support processes, and outcome measures. So you can see here in these 53 measures, the majority or the most frequent are pre-analytical, as we would expect, as much of the errors occur at that stage. There's 6 intra-analytical processes and 9 post-analytical that are mandatory, and then 5 of each for support and outcome processes. So of course, it can be overwhelming to begin a process of validating 53 different measures. So the IFCC actually has recommended that labs can initially select just the most appropriate quality indicators. For example, start with the mandatory quality indicators and then start building from there to make it more feasible. And that brings me to the clinical lab quality indicators and harmonization across the GTA. So the aim of this group is to harmonize quality indicators across hospital-based clinical labs to identify areas for quality improvement and sharing of best practices. So you may have heard so far, there was a survey conducted of 15 hospital-based clinical labs, the core lab quality indicator survey, which and then as a result, the group promotes the IFCC model of quality indicators, and therefore there has been a proposed list of harmonized indicators. And these are all available on the LMP Quality Council website as well. And these are the key quality indicators. So there's in the pre-examination phase, it's been proposed to monitor misidentification errors in incorrect fill levels, hemolysis, and clotting. In the intra-examination phase, unacceptable EQA performance, and then also several turnaround time indicators such as for stat potassium, INR, white blood cells, and troponin, and then time to notification of critical results. Also, it's been recommended by our group that the monitoring or reporting is performed according to the IFCC harmonization model. So this is what I'm referring to as doing the math. So in the pre-examination phase, we're monitoring the percentage or as a function of the total number of orders for these different pre-examination phase QIs. For the intra-examination phase, again, we're monitoring the percentage or the number of proficiency testing flags as a function of the total number of challenges. And in the post-examination phase, again, the percentage, so the number of results that are outside of the specified turnaround time versus the total number of released results. And importantly, also tracking the turnaround time at the 90th percentile. And actually in our lab, we've made some changes already in this regard. So to summarize then the work of the LMP Quality Council, the Quality Indicators Working Group, the common quality indicators have been established with high impact on patient safety across the GTA, following the IFCC model. And I'll briefly also mention how the group now is utilizing the SQBC program to compare QIs to further improve lab efforts for continuous improvement. So the SQBC program, it's a program out of Quebec, and it's a user-friendly web-based platform where users can register and submit their quality indicator data for comparison. And here I just noted some of the leads for this group. So we've been able to build on this platform that has been created already for a peer comparison. So this is just a screenshot of their website, and you can see you can submit your data for a turnaround time for troponin and potassium, as well as hemolysis data and misidentification errors. And at the end, you'll get personalized and interactive reports after each submission cycle, and you can follow your performance over time and compare to how other labs are doing. It shows you box plots and distributions of data, and you'll see this in detail. soon. And then multi-site users also can, you can plot, if you have multiple sites, you can obtain data, interactive reports for each of your sites in a graphic a summary, and they can be personalized. So this is a very nice platform that we've been utilizing. So just, and now I'll just pass along to the other speakers who'll talk about all of this in much more detail, and with a focus on turnaround time and hemolysis rate at different hospitals. And we definitely invite lab as well as hospital leadership with interest in quality management to join these discussions and participate in this interactive workshop. So thank you. We'll have, I don't know if we have time for 1 or 2 questions.
Thank you very much, Lucia. We do have time for a question if someone would like to ask. Dr. Vincent Dr, please go ahead.
Hi, thanks, Paul. Great work, Lusia, for your presentation. I just want to make sure that one of our priority in the WG-LPS for next year is to come up with a more restricted panel of priority 1 quality indicators, because right now, I mean, there's around like 30-something priority 1 QI, so it's extremely difficult for laboratories to participate to all of these QIs, and also it limits the number of laboratories for comparison for each QI. So we're aware of this, and it will be important for us to let's say decrease the best QIs that people should follow to start.
Yeah, I agree. I mean, if we look at starting to monitor 53 in total, or start with the number that is out there, I think collecting data could be a daunting task for labs. So I completely agree, and that's why in also in our local working group, we had proposed those only key quality indicators to make it more feasible and more bite-sized. So yeah, I completely agree. And thank you, Vincent, for joining us.
My pleasure. Such a great initiatives. You guys really rock with this session. Congrats for this.
Okay, thank you. And in the interest of time, I'm going to move on to our next speaker. So thank you, Lucia. And if I could ask Dr. Davor Brinc to have his slides ready. And so I'll start off by introducing Dr. Brinc. Davor Brinc is a clinical chemist at University Health Network, and also assistant professor in the Department of Lab Medicine and Pathobiology. Davor has been working very closely in the Quality Aid Indicators group, and he's also been working on the Critical Values initiative that's part of the Quality Council. But today he's going to focus on a topic relevant to quality indicators, and that is turnaround time. So turning it over to you, Davor.
Well, thank you, Paul, for the introduction. I hope everybody can hear me. So in the meeting today, we'll be covering 2 quality indicators, not all 53. So one will be the turnaround time and then the hemolysis rate. I will be focusing on the turnaround time for the first half, and then Saranya will take over for the hemolysis rate. I have no conflict of interest to disclose. So the objective of this talk is to, first of all, introduce everybody to the turnaround time harmonization initiative, and then really focus on one aspect of this initiative, which is the submission of turnaround time data to a peer group. You will immediately after this talk, we'll have breakout rooms where some of the topics will be discussed, hopefully in more detail, in more interactive fashion, but the objective is the same. So first of all, just to get everybody on the same page, what is meant by a turnaround time? So if you look at the total testing process, which includes a number of different steps, so this is one way of presenting this total process. There are a number of different elements. We have test order, collection, sample arrives to the lab, processed, analyzed, eventually have the result verified and released, and hopefully this can lead to a clinical action. So each of these steps will have sort of its own timestamp associated with it, although we're all well aware of that the timestamp for each of the event and the actual event could be very different. This is especially problematic for collection events, which I will touch upon later. So the turnaround time is then really a time difference between any of those 2 steps. And the two most common way to calculate this difference is the difference between the time of result release and the time of collection. This is sometimes referred to as clinical turnaround time, and this is how the IFCC describes it. Then there is also the difference between the time of release and the time the sample arrives to the lab, which is called analytical turnaround time by the IFCC. Now, in the literature, one can come across this term called therapeutic turnaround time. And this is really a difference between the test order and the actual clinical action. So it's something of interest to clinicians and patients, but of course, for the lab, from the lab perspective, this will be very difficult to capture it in any meaningful way. So the turnaround time is a time difference. That's simple. But then the turnaround time performance can be summarized in a number of different ways. So these are so-called turnaround time metrics, which is different from the actual turnaround time measurement. So if you look at what different people are doing, what's being published, you can see a bunch of different metrics out there. You have the average, the median, the percentiles, and here we have different percentiles. Then you have percentage of acceptable results, a proportion on unacceptable results using a large number of different cutoffs that people select. Now, what is not always appreciated, though, is that well, turnaround time metrics doesn't perform the same in different situations. There's actually a way to evaluate each of the metric. So using, for example, measures such as confidence interval or precision, or even sensitivity, specificity to detect a change in turnaround time. And there were earlier studies done back in the 80s and 90s, particularly by Wallenstein, who actually introduced some of these concepts of turnaround time metric performance, and has shown some of the main factors that affect this performance. And this has been replicated by more recent studies by different groups. So some of the things that can affect how your turnaround time metric behaves is certainly the sample size, it's kind of obvious, and also the distribution of the actual turnaround time values. And there are, of course, other factors that I don't have time to go into. So as a way of it, just to give you a taste of this, on the left here, here I'm looking at the 90th percentile for the collect to receive turnaround time for potassium. So this is data based from Toronto General Hospital. I just simply took the subset of different sizes and then calculated the percentile and the associated confidence interval using the NIPE method. So, as you can see, and as can be expected, as you decrease the n value, the sample size that you use to calculate your metric, the confidence interval becomes increases and can become quite unstable. So in fact, anything less than 1,000, at least based on this data set, should not really be used to calculate your turnaround time metric. On the right here, this is a graph from one of the recent publications. And here what the authors did, they looked at the sensitivity. They also looked at some other measures, but I'm only showing this. They look at the sensitivity of different metrics to actually detect a change in turnaround time when it actually occurs. So here I'm just showing, for example, a proportion of acceptable tests using different percentiles as cutoff. So you can see again the effect of sample size. If your sample size is quite low, you will not get a very good performance. It almost becomes meaningless. But even at the very high sample size, so at the sample size that will give you a decent confidence interval, even here you can see different performance. So for example, if you use 95th percentile as a cutoff, you get fairly good sensitivity, but at 75 percentile, that sensitivity goes down. So the bottom line, your choice of turnaround time metric should not really be arbitrary. There is something about performance that you do have to worry about. Okay, so now, Jenny, if you can pull up the first poll question. So you will notice that throughout this morning, we'll have several poll questions. So this will be for turnaround time and for hemolysis rate. Just for us to get a feedback from you to see what your thoughts are. So this is question one. It's the easiest one, but just to get things rolling, which is asking you to note which turnaround time do you monitor your institutions? Analytical, clinical, therapeutic, which I don't really expect anybody to monitor, or you don't monitor any at your institution. here, so we can stop the poll one. So as you can see, and this is quite expected, the most of the respondents selected analytical turnaround time. And this, in fact, has been borne out by a number of different surveys. It's the easiest turnaround time to collect, and this is why most responders would go that way. So, as Lucia briefly touched upon, LMP Quality Council did conduct a survey about quality indicators, mainly involving several large GTA hospitals. And some of the questions were around the turnaround times. So in this example here, when asked about turnaround time, which turnaround time is being actually determined, again, as you have seen in the first poll question, most people would collect the so-called analytical turnaround time from receipt to result. And about half of the respondents also collected the clinical turnaround time. And most of the time, this has to do with the ease of sample collection. We did ask some other questions. So if you're looking at the type of tests that people tend to measure turnaround time on, you can see most people would measure troponin, white blood cells, PTRNR, and potassium or some other electrolyte. Although there were some other tests being listed, particularly blood gases, the other one that's most common. But then you have this more specialized ones, so ACG, fibrinogen, even glucose, and so on. And in terms of the locations, most of the time the turnaround time is monitored for emergency department, but then you do have like diverse other areas that are being monitored, pretty much dependent on the type of hospital that we serve it. So you have ICU, oncology, and so on. Now, we also asked about which metric is being used. And in this particular question, we used which percentile is being used to assess if turnaround time missed the target. And interestingly enough, we did see some diversity. So while most people indicated they use 90th percentile, people do use some other ones, which we found quite interesting in terms of the knowledge about different performance of different metrics. So the bottom line is what this small survey has shown, and there are other surveys in the literature conducted by different organizations. The main conclusion is the same, and this is that there is certain degree of heterogeneity in using turnaround time as a quality indicator. So both in terms of what is measured, your choice of metric, how frequently you collect the data, what kind of internal benchmarking you use. And if I want to ask why would that be, I can think of the goal of institution may be different, the clinical area served by the laboratory may be different, the patient population may be different. In any case, certain degree of heterogeneity certainly it should be accepted and it may be justified. However, there is this global interest, so to speak, to achieve a certain degree of harmonization, and especially to achieve to realize what the standards of turnaround time performance actually are, and then to try to achieve this level of performance across many different laboratories, no matter where you are globally. So IFCC, as Lucia mentioned before, did start a working group on laboratory errors and patient safety. This was back in 2008. And one of their goals related to turnaround time was to develop a consensus, first of all, on which tests should be included in the turnaround time metric, at least minimally, and then which actual metric to use. So always keep in mind the performance of different metrics is not the same. And then there was this idea to develop adequate platform for peer comparison, where people anywhere in the world can submit the data, and with the idea to help with this standardization and also to help set benchmarks for what could adequate performance mean. There is also European Federation of Clinical Chemistry and Laboratory Medicine group that specifically is looking into what would performance specification for different quality indicators, but also especially for turnaround time look like. This is a more recent group, and they have not yet published any major findings, but they're not related to the IFCC initiative. And as Lucia described, there is also Canada-wide initiative driven by SQBC that did set up a program for quality indicator comparison, including turnaround time. And I will spend the second half of my talk talking about this platform. And of course, there is LMP Quality Council leading this harmonization initiative from IFCC locally. So as Lucia mentioned, IFCC did publish a model of quality indicators. You can go to their website to get a full list and description. So for turnaround time, what they sort of recommend would involve turnaround time for potassium, PTRNR, white blood cell and troponin. And as you've seen in our survey, those are the most common tests that people measure. In terms of metrics, they selected 90th percentile and also the percentage of results that are released over an hour for potassium and similarly for troponin. They did focus on analytical turnaround time and also focused on stats tests only to reduce the impact of differences in lab size and workload. And you have to keep in mind that this choice, to some extent, was driven by this need to develop a platform for peer group data submission. So they wanted to select something that people will have less problems with submitting the data, and also to take account of the fact that lab sizes and workloads, instrumentation can be quite different. So again, one of the main steps in harmonization is to have this peer group data comparison. Well, this is not so new. I mean, there were peer groups for turnaround time that has existed for some time. So for example, you have Q-Track in US especially. There are different manufacturer platforms that could be used, for example, from Abbott. And there are other business analytics type solutions where you can get some degree of peer data together. For example, from within Epic, there is some functionality. Now, IFCC has, as I said earlier, did develop their own platform. This is their website where people can subscribe and register and then submit data. But for Canada, SQBC has developed their own platform for Canadian laboratories, and this platform also shares the data with the IFCC. So Jenny, if you can pull up the second poll question. So here what we're asking is, do you currently participate in any of the peer group comparison programs for turnaround time? So are you even aware of it? You're not aware of it? And if you are aware of it, which one do you actually participate in? Okay, well, the responses here are more diverse. So about 40% actually are not aware of a peer group program, but it's great. Our presentation is on time. Many are aware but do not participate. Of course, participation carries some investment in time, so that's quite expected. There's a Q-Track, SQBC. Nobody submits to IFCC directly. You don't have to because you have SQBC. It's quite a diverse response, so that's quite interesting to see. And we can come back to discuss this in one of our breakout rooms. Okay, so for the rest of my talk, I will focus on the SQBC peer group program. This is a snapshot of their website. This is the link. For turnaround time, several metrics are being collected. So basically for troponin and potassium, for analytical and clinical turnaround time for outpatients or ED patients. They're looking for 90th percentile or percentage of tests released within 60 minutes. The program is open Canada-wide, and they intend to recruit as many participants from Canadian labs as possible. So there are a few slides on what, from practical perspective, what this would involve. So first of all, you have to have a source of data, which is not always easy to get, I might say. So this will be an export of LAS data usually. And the data to include would at minimum be a specimen identifier, different timestamps, patient location, testing location, especially if you have a site with multiple testing facilities. So you have to worry about sample rerouting. It'd be useful to know which test is an add-on if that's possible. Some of the other information that would be necessary, although not absolutely necessary, the centrifugation time and the reaction time. You do have to do a certain degree of data processing, removing duplicates, add-on as possible rerouted samples and observed results, and then calculate the metrics that the website, this platform requires. So LMP Quality Council has actually prepared a template that can facilitate Excel template, which can facilitate submission to this website. So once you clean up your data, you can copy the things in this template. Mostly you can use just timestamps. It will then calculate all the metrics as needed for submission. It also allows you to enter certain information in one spot that you will need when you submit data to SQBC. And then you can take the summary and simply copy into the onto the SQBC platform. So you're not submitting actual individual data points. I should say this data is collected 3 times a year, so certain months during the year that the data is collected, and you're submitting turnaround time data covering the period of that particular month so that the survey is being opened. So you can think of this as a proficiency testing for turnaround time. So once the cycle is closed, you get a report. I'm just going to show you just an example graph that you can see from this platform. This is an example of analytical turnaround time at 90% of potassium for ER. So on the x-axis, you have the cycle, and on the y-axis, you have the turnaround time. So you see these box plots, which has the median, the quartiles, and the minimum maximum, as well as the outliers. So your site, so this is UHN in my case, is shown as a dot, so it's differently colored than the outlier. So you can see how you position relative to all the others, and then how you track over time. I should say that your site is visible only to you when you log in from your as your site, and it's otherwise it's anonymous. There is a plan to create a GTA-only subgroup, so it will depend if you have enough participants, in which case the cluster of points for the GTA-only subgroup would be shown on the background of all the other users. So this is still being developed. This is just an example for troponin, but this is not something that's live yet. Now, SQBC also provides benchmarks, and it takes the ISCC approach to what this benchmarking should look like. And this is basically a state-of-the-art approach, which is, if you recall, Milan conference for analytical goal setting, it would be the model 3. So the idea is that you take a period of time, let's say a year, you collect the data from all the users, and then you find the percentiles that you're going to designate as a cutoff for acceptable or unacceptable performance. So in this particular example, this is data from 2018. For potassium for ER, less than 43 minutes would be high performance, that's less than 5th percentile, and something above 57 would be unacceptable. So again, this is also being in development to some extent, but this is how things are currently. Okay, so our last poll question for turnaround time is this. So Jenny, if you can pull it out. So the question is, how would you use peer, if you obtain something like this, a report of this kind, what would you do with such data? You have an option, you would implement whatever is being recommended, you would implement the test or the metric, you would totally ignore it, or you would use it as an internal benchmark. Okay, well, again, interesting, the diverse set of responses. Most people will use it as an internal benchmark, but less people would actually go and implement the same test or a metric, which is interesting. And it's something where we can also discuss in one of the breakout rooms. Okay, so before breaking out on the end of my talk, I just want to make one last point, which is, just to put things into perspective, why is the turnaround time important? And here you need to think about the impact eventually on the patients. So this has been opinion voiced by a number of papers, especially from clinicians. So even when you're dealing with a process indicator such as turnaround time, it's important to link it somehow to the outcome. So for example, for turnaround time, one obvious link would be the link to length of stay. Of course, this is something that will be very hard to establish because there are many confounders. I just quickly give one example from a relatively recent study, but those studies are few and far between. They try to establish this link. So they looked at turnaround time across different similar hospitals and found actually an association with the length of stay. They even came up with a regression equation where if you increase the turnaround time outlier rate, you're going to have increase in length of stay. And for one side, they followed improvement in turnaround time, which led to the decrease in the length of stay. Again, you have to take this with a grain of salt. There are many confounders that can, hide here. But the point is that you always try to, even if it's a process indicator, you try to make it clinically relevant. You have to put it in the right clinical context. Okay, so the idea now is to break into different breakout rooms that will handle different topics that was briefly touched upon in this initial part of the presentation. So each of the participants will be randomly assigned to one of the groups. And the idea is to have a smaller group size to facilitate discussion, get feedback, and get a sense of what people feel. This will last about 10 minutes, and after that, there will be each of the room will have a moderator, and each moderator will then present briefly what was being anything that was being raised, and then we'll have a conclusion and a final question and answer session. And again, reminder: breakout room is not recorded, so you can say whatever you want. Okay, well, we are back together. Hopefully everybody has joined the main room now. There wasn't much time for great discussions, but hopefully moderators did receive some degree of feedback. So we're going to spend just a few minutes on for each moderator to present a summary from their group. I was in group 1, so I can just briefly say what was mentioned in my breakout room. One of the main issues was raised is to have a adequate commitment to something like SQBC data submission. Who will be the main person responsible for collecting data, submitting data, and then presenting data? If you don't have the level of commitment at the, for example, quality management staff level, then how is this going to be maintained? So providing a sort of a guidance by LMP Quality Council to have facilitators locally would be one of the main challenges. As you know, in a regular proficiency testing program, you have to have a commitment because it's part of accreditation requirement, which is not the case here. So you're going to have that issue of continued participation, which it's thought that the LMP Quality Council can address. So this was the main comment from my.
Okay, the second question that we discussed about at the topic group 2 is the barrier to participate in the quality indicator program. The main discussion was about data access, and in terms of limited to the data, is not really reliable built in. And some site mentioned that they have informatics for years. They cannot even put in the sample collection time. So clearly the clinical turnaround time would not be accessible or not kind of reliable, as well as we hear some comments from the community lab that basically can have a different setting from the hospital. They have the next day service. They not really think that they would fit with this, participate in the QI. The clinical turnaround time is not that like focused the way the hospital is looking at. Another thing that we were also mentioned in terms of the metrics of 90th percentile, it does present as a 10% failure. Do we really accept that? Should we reconsider 95th percentile, 97.5th percentile, and so on? So it was interesting, but mainly it's clearly about the reliable data. How do we get access to those data? That would be, again, the barriers.
So our third breakout group discussed making the turnaround time indicator clinically relevant, and some interesting and approaches, and I think that were being used by others is choice of tests, and I think there's some kind of standard tests that have been discussed here, like potassium or troponin, but some labs, for example, use beta HCG turnaround time monitoring, and that is due to clinician feedback and clinical demand. So I think stakeholder engagement is another kind of a topic. How can we make it clinically relevant, and then performing quality improvement to meet clinical needs, and then also talking about selecting the right metric in terms of location So do you, for example, emergency department or monitoring the right location that has that turnaround time requirement was another metric, I think, that was how to make it clinically relevant. And then we briefly talked about using peer data for quality improvement. And I think there's some variability in whether the data is helpful or not. So we didn't have a chance to, there was a great discussion points brought up, but we didn't have a chance to discuss this at length, but these are some of the points.
So the next breakout room, we talked about, actually, Lucia, following up on you, what to do with peer comparison data. We spoke mostly, because Vincent was in the room, about the SQBC platform. And there is definitely value in just seeing how you compare to other sites. But the discussion was, as SQBC gets more subscribers, then you can get into more granularity and have more of an idea of what how equivalent are your comparisons. So, for example, I mentioned that recently Roche a few years ago came out with a stat troponin. So if we had more peers, it'd be very helpful to know, is our stat troponin really in line with what Roche is recommending in terms of how quickly they can turn around that test? And is that also what they see with other peers who are on this specific assay for Roche troponin? Beyond that, right now, I also said that personally, I have found value in seeing what happens before the sample comes to the lab and seeing how we match to other sites. I think typically labs are very good at controlling what happens after the sample is received, but seeing what time it takes against other peers before the sample comes, that really gives an idea of how well can we align and better our turnaround time pre-receiving by the lab, especially seeing how other peers are doing.
Hi, so in our breakout room, we basically discussed what would be included in the peer comparison data. Some of the sites basically mentioned what was suggested by the by this group, like a GTA LMP group, troponin, for example, and potassium. Some of the sites are already doing this, and some of the sites are doing some of the other markers or analytes, and they do it based on the analyzer. So, for example, some of the, they will take a representative sample from each of the analyzers, which is something that we do at North York Hospital as well. And most of them are, at least some site mentioned that they are actually, comparing the data within, their sites. So some of the, some of the organization, they have multiple sites, and so basically they are comparing. None of them actually, obviously, submit the data to SQBC currently, and so they are basically monitoring the data to compare their sites, how they, how well they compare, and also, there are questions about, or whether or not there's a value to participating, particularly if one particular site had a very small number of beds, for example. How would this help? Participation help that small site, and how would you do the comparison really if you don't have the the filters that we talked about, does my small site compare to the big site, or it doesn't really compare? So then what's the value in participating and putting all those hours and manpower and labor at the end? Am I getting anything out of it really? So suggestion for perhaps more filters, more comparability, and so on and so forth.
Okay, so thank you for the summaries. We'll be also putting the summaries together after the talk, and hopefully provide it to everybody. I see Vincent has his hands up. Vincent, do you want to comment before I go to conclusion slide?
Yeah, very, very quick. I just want to mention, guys, that accessibility of data is the biggest challenge everybody is facing, and I'm just seeing that so many people are involved right now in your meeting. So don't underestimate your power to reach out to LIS companies and mention that, for example, your lab is not able to participate in a comparison program because it's impossible to extract the data. We had this kind of discussion with some vendors in our province, and they provided standardized templates based on the QI's program, so their users were able to extract data easily and participate to the program. So if this is the limiting step, and I think we could work on this at the national level as well to have a strong power of this, but I think we shouldn't hesitate to reach out to LIS companies to have support to have access to the data. Standardization is the key here. You know, like participation in the pre-analytical quality indicators is a big challenge for laboratories. To overcome this, we did a big initiatives on standardization of, I would say, sample rejection classes to implement in a new provincial LIS in Quebec. We will bring this project at the EFLM pre-analytical working group and the IFCC working group as well. So don't hesitate to start standardizing your processes between laboratories to facilitate participation. And my last comment would be on the 90th percentile. I totally get the point that, you know, like it would be better maybe to follow the 95th or 97th percentile for the turnaround time. However, we thought that the 90th percentile was the best balance, including as much as possible data, but also not including potential outliers related to the challenges of data extraction.
Exactly. Thank you, Vincent, for those comments. And yes, please remember the metric has a performance that you can evaluate, and you know, this is something that we can also be involved in. Why would one metric be better than another? Okay, for conclusion, this is, well, sort of a conclusion slide. Based on the feedback from the breakout room, so one can really see there is a benefit and there are barriers or issues with generally with harmonization of turnaround time and also participation in a peer group program. So this is just one, you know, my take on this. You know, what would be the benefits? Certainly using the harmonized data collection methods, you know, as Vincent just mentioned, involving the LIS vendor in achieving this, use a harmonized metric that has a good performance, having this ability to compare with peers. And the more participants that are, we can then focus on specific subgroups, you know, based on hospital size, based on instrumentation, and so on. But it really depends for people to have enough participants. This is also a thing about the future. This is a way to have a voice sort of in local to international harmonization initiatives, and also help set up, you know, something that's some standards that are clearly relevant. Of course, the barriers are, again, the data access, the processing, and then using this data from peers or from harmonization initiatives locally, how to make this relevant to your own institutions. So with that, my part of the talk will conclude. I just want to acknowledge the LMP Quality Council, which is chaired by Dr. Adeli, as well as Vincent from SQPC, who actually set up the platform. So thank you. We can now go to questions. We have to then move on to another presentation.
Great, thank you very much, Davor. And it's really good to hear the breakout rooms have been very successful. We do have time for one question. If people would like to ask, you can raise your hand and unmute your line, or you can ask through the chat box. This is a question. Go ahead.
So Christiana is asking Vincent, actually, that if you could expand on the LIS companies that seem to be out there and could be helpful.
Could you repeat that? Which LIS company, what?
Could you expand on the LIS companies that seem to be out there and that could be helpful? So maybe the ones that you contacted and actually got a good feedback from? Yeah, so we used to have a lot of limitation with an LIS called Omnitech. I don't know if it's a system that is used in Ontario and across Canada. That was like the main barrier for the people to participate. But they were really open to work on this and do some templates. I think we're using SoftLab. Actually, that's a huge challenge, but I think there's going to be a lot of benefits. We're moving on a provincial LIS
using SoftLab. And it's the LIS I've been using in my hospital for years. I think they're really good about the capacity of data extraction. The challenge we have as well is even if you have the same LIS, it's not built the same way in the different sites, right? So some people can access easily the data and others don't. And you discussed also about who should be involved in the QI initiatives. And that's very key here. So you can have like a very good LIS, but if the politic of your institution is to limit access of data to key people, like LIS people, and you're not able to have access to the data, that's a big problem as well. One possibility in the platform, you can have multiple people involved for the same sites. So you could have your quality people that subscribe for your site, yourself for the report, your LIS folks for data extraction. So that's a way of facilitating the process. But, you know, we've been discussing a few times about the value of having, you know, like a conference discussing the limitation and challenges of different LIS. And the goal also would be to share the tools that people develop. I saw a very nice tool from Paul for his LIS. So, you know, like to share these kind of tools for data calculation as well.
All right, great. So sorry, I'm going to have to close this particular presentation. So thank you again to Davor. And we're going to move on to our third speaker. And Saranya, if you could get your slides up and ready, and I'll introduce you. And so I'd like to introduce Dr. Saranya Arnoldo. She's a clinical biochemist at William Osler and also Trillium Health Partner. She is assistant professor in the department. And in the Quality Council, she's been contributing to the core lab quality indicators and also to the critical values initiative. And without further ado, I'm going to hand it over to Saranya to speak about important work that she's done at William Osler regarding hemolysis. Go ahead, Saranya.
Thank you, Paul, and good morning, everyone. For my session, I will review the journey of blood sample from the bedside to bench using the hemolysis as a quality indicator. I would like to declare I have no conflict of interest anywhere. So my learning objective will start with contributing factors that lead to hemolysis in the blood samples. So quickly, hemolysis is basically defined as a process of membrane destruction of red blood cell or any other blood cells. And that leads to the release of hemoglobin and other intracellular components in the serum or plasma. Hemolysis can occur either in vivo or in vitro. For my discussion today, I will only focus on the in vitro hemolysis, since it is the most common preanatal error and accounts for more than 60% of sample rejections worldwide. So here I am showing you the CAP survey back in 2015. They surveyed more than 700 laboratories about percent hemolyzed sample in their lab. 1/3 of the labs say they have a very little hemolysis rate of less than 1%. 1/3 say, okay, 1 to 2.9%. And interestingly, only 8 labs out of 772 labs stating that they have very high hemolysis rate of 15% or greater, and 9% or 71 labs do not know what the hemolysis rate at their hospital. So now my question to you all is, do you know the estimated percent hemolysis rate at your hospital? If you can share with us in the chat box, we would like to know. So hemolysis may adversely affect patient care via delay related to repeat testing, patient dissatisfaction, and discomfort associated with the repeating blood draw. So we also have many confounding diagnostic processes, prolonged turnaround time, and diagnostic error. So in this study, it assessed the effect of hemolyzed blood sample in the light gray compared with the, light gray is non-hemolyzed compared with the hemolyzed sample. And they used the ED length of stay as the primary outcome measure. And as you can see, the non-hemolyzed sample has 60-minute less length of stay in the ED. So it is really significant. So is hemolysis a big problem? So we talk about number one, rejection rate, right? So here in this study, it's also found that within 1 year period, hemolysis is a significant error in the biochemistry unit. So at Oslo, we also pull data to determine in terms of the error that happened in our lab. We found that 85% belong to preanatal error, and not surprised, 40% of them belong to phlebotomy techniques. And our data is also showing that hemolysis is number one reason for cancellation as well. So many factors that most commonly associated with in vitro hemolysis are summarized here, starting from phlebotomy, transportation, preparation, and storage. So although we have a standardization process and it has been improved in the past 20 years, we still see that the phlebotomy is still the most common cause of hemolysis that happen in the laboratory. So now let's start our journey at the bedside. This study used to present inappropriate equipment that lead to increased hemolysis rate. For example, starting from the device, if you draw the blood from the IV catheter, it showed higher hemolysis rate compared to butterfly needle. With the blood draw, needle gauge size doesn't matter. As you can see, hemolysis is inversely proportional to diameter of the needle used. The wider bore needle associated with increased turbulent flow, pressure, and high incidence of hemolysis. And lack of mixing or even excessive mixing is also lead to hemolysis. So in this case, if you draw less than half full of the blood tube, you can see that they have increase more room for blood to move and thereby increased hemolysis rate. Tunicular time and also difficult draw is also lead to increased hemolysis. Another thing to consider is improper placement of the needle. If you insert needle not far enough, too deep, not the right angle, that could also lead to hemolysis as well. Another interesting point is that hemolysis is also associated with the pressure of the blood collection tube. So the higher pressure, the more free hemoglobin is released, and that could lead to hemolysis as well. So when the sample is collected, it can be transported to the lab by manual or pneumatic tube. So after packing sample in the carrier will then position in the sending station and dispatched to the destination through this kind of network of the tubing. So these present studies show that the pneumatic tube can cause hemolysis, and the author has indicated the air vacuum as well as the pressure that used to speed up the carrier could contribute to an increase in hemolysis. At William Oslo, when we implement the pneumatic tube, we also validate the pneumatic tube system just to make sure that this is not causing any hemolysis. So this study, we use potassium as the test marker. So when the sample reached to the lab, we do also prepare the sample by centrifugation. So the time, the speed, and temperature of centrifugation can also make a key important role for sample quality. In this case, the study from UHN, when they changed the centrifugation speed, you can see that they use the hemolysis index measurement, and as you can see, there is no difference. For us, we also measure potassium as one of the indicators that there is no difference when we change the centrifugation speed. Okay, so now when we get the sample, how do we detect hemolysis in the laboratory? There are two main approaches that commonly used. The first one is the visual inspection of a specimen. It is done after centrifugation by comparing plasma or serum with the hemolytic charts shown here. The different shade of red shown in the color of sample with an increasing concentration of the free hemoglobin. At the conventional hemolysis cutoff of 0.5, you can see that there is a color of mildly orange, and then color is really turning red and darker, right, up to dark brown. So that again show an increasing amount of free hemoglobin. In terms of visual inspection, the manual processing is very subjective, and really the accuracy of this approach has been seriously questioned. Another way to detect hemolysis index is by spectrophotometry using the automated analyzer. So in this case, hemoglobin is absorbed the light very strongly at the wavelength between 340 to 440, and the highest is around 415. And another reference is around 500 to 580 nanometer. The principle of the measuring basically using the multiple spectrophotometric absorbance reading. And then it also covered the peak absorbance of 3 interfering substances shown in the graphs. And with the manufacturer, they would use the algorithm, the correction factor, basically to resolve any possible spectrum overlap. So there is also a limitation because there is really not standardized or harmonized that I will mention after. So as mentioned earlier, visual inspection is subjective and can be time consuming. Therefore, it can cause a delay of reporting. So let's compare the visual inspection as well as compared to the automated measuring of hemolysis. In this study, over 1,700 samples was determined, and as you can see, the discrepancy as shown in red between visual and automated platform, and see about 6% discrepant. Visual detection also vary from one person to the other. So in this study, they have the technologist A as a reference, and you have another 5 technologists compared with the technologist A. The mean kappa show about 0.6%, which is very poor. So this really showing that visual inspection doesn't show any good agreement with, okay agreement with automated, but still vary between personnel. So with this, visual inspection of hemolysis is not recommended. So can you please poll the first question, Jenny? Do you measure hemolysis on chemistry sample? If so, how do you detect it? Number 1, you do not measure hemolysis at all, or yes, you measure by visual inspection, or you only measure using HIL indices from the automated platform, or you are doing both. Or you do measure, but you really don't know where do you get the hemolysis index value from. Yeah, so the majority of people use the automated platform, and some also use both, which is good. I'm going to show you how we do. So at William Osler, we also use the automated analyzer to measure hemolysis index. So when we calculate the hemolysis, percent hemolysis rate, excuse me, we use the HIL, excuse me. We use the HIL indices from the main analyzer, and based on the hemoglobin concentration. In this case, anything below 0.5 we graded as not detected. So all the chemistry sample will measure hemolysis index, and anything above the cutoff we graded as 1+ to 4+. So the percent hemolysis rate we calculated as the total number of 1+ to 4+ divided by the total number of hemolysis reports. And here is our overall hemolysis rate per month, which is, as you can see, is around 10% hemolysis rate. And I thought, okay, it looked quite high, but how are we compare with other hospital? So then we would like to basically compare our data to the national report. So we participate in SQBC since 2019, and I learned about SQBC from a CSCC conference back in 2019. So the first thing I did was coming back and then let's submit the data to the SQBC. So as you can see, with the cutoff they use is based on the IFCC of free hemoglobin of 0.5 gram. The percent hemolysis calculation is similar to what we did. So 2 data submission required is the rate of hemolysis and the denominator. In this case, we use a total hemoglobin report at our hospital. Here is our data from 3 hospital sites, and as you can see, from 5%, 9%, and 12%. I'm not going to tell you which site, but look like the majority is quite high because the median is around 1 or 2, and then there is one site that is about 25%. So then I thought, oh, are we really that high? So I reached out to my colleague at Mount Sinai, and the Sinai present only 3.7% hemolysis rate. And I thought, wait, we are using Siemens platform and Sinai is using Roche. Are there any difference between the two platforms? So the potential issue that I can find is that different measurements from a different manufacturer, even though they use the same theoretical approach measuring the spectrum, there is still a difference in terms of the approach using the wavelength used to basically correct the potential interference. So it is a poor harmonization among the manufacturer. In this case, as you can see here from the main 5 vendor. Another thing that I found out is that the different cutoff that used to determine if the sample is hemolyzed or not. These tables summarize the poor present the poor harmonization of the hemolysis index using the different cutoff. For example, Siemens, we did validate and we changed it to 0.5 gram with the index of 0. The Abbott show less than 0.3 that would show as the blank in terms of their grading. Roche, on the other hand, do not have a clear information for us, but this grading is actually validated by the customer as a 0.4. Beckman present of 0.5 grams, showing that no hemolysis, whereas also again do not provide by the company. This one is the customer validation, less than 1.2 gram, which is quite high for us. So in this case, I can clearly showing that it is a poor harmonization for both measurements as well as the cutoff used for hemoglobin. So the IFCC European Federation has published a call for more transparency in manufacturer declaration of the serum indices. So now I did reach out to Sinai, and then Mount Sinai has changed their cutoff. And then we monitor the monthly hemolysis rate. And as you can see, William also shown in blue, and the red is Mount Sinai. After the cutoff has changed, the percent hemolysis has shown very similar to William Osler. Now Sinai meet Osler. So another thing to consider in terms of different lab has different practice, different approach in terms of calculate hemolysis, percent hemolysis index. So when we do the measurement from the instrument, that is what we measure, but then now we have to calculate what we call metrics. We can do by percent of sample. That we did is the hemolysis index above 0.5 divided by the total chemistry sample that we measure. Or some labs do not measure every single sample, but measure hemolysis only sample that have potassium test order. So in that case, the denominator will be different. Some hospitals do not report a trial at all or do not really measure, but do put the comment attached to potassium. So in that case, the calculation percent hemolysis could be coming from the potassium comment divided by total potassium test results. Or another way, some hospital might calculate the percent sample rejected by hemolysis. That could be another good indicator as well. So just to keep in mind, the way we calculate A, B, and C may not be the same. So I reached out to another hospital in the GTA, and the result is a little bit too extreme, very, very low, 0.49, 0.7 hemolysis rate. And after discussion, we found that the lab has used the number of samples rejected. Basically, this is the percent rejected due to hemolysis, not the hemolysis rate. So again, to do a peer comparison, we have to make sure that we compare the same thing. So now when we reach out to USN using Abbott and has changed their cutoff of hemoglobin from 0.3 to 0.5. 3 sites at USN, you can see that one site agree with Osler and Sinai, but another 2 sites from USN has shown a very low hemolysis rate. So now once we have seen all those hemolysis rate across kind of compared to your peer, how do we use the national report to create opportunity for improvement? So if you can pull the second question, how do you handle hemolyzed sample in your lab? So you can say, no, we do not measure hemolysis in my area at all, or you basically reject the whole sample, or some only rejected on some affected tests along with appropriate comments. Or basically you release all tests with a general information of hemolysis. So basically one common generic comment. Or you release the test regardless of interference. You never report hemolysis. Okay, so the majority of the lab, I think we have a good number. Thank you. So the majority of lab do pretty much the same as us. Some, we only reject some of the affected tests with appropriate comments. So what are the large survey percent in this case? It is done in the 37 countries in Europe, more than 1,400 laboratory response. And as you can see, almost 100% of the lab presented that they do measure HIL. And very minor, maybe less than 2% saying that they do not have any HIL checked. Very interesting in this paper showing that even though they measure hemolysis in the laboratory, but 30% of the labs still detect hemolysis by visual inspection. And 2/3 of that do visual check even without the hemolytic scale. So we already discussed how unreliable visual check is, but it's still quite surprised to see that high number of the lab do not measure using the automated platform. And in terms of the harmonization of the cutoff of free hemoglobin as the cutoff, you can also appreciate that many labs still have the different cutoff, which is pretty much the same as us. The majority of labs use 0.5 as a cutoff. And then some lab also say they use the visual decision. So now when we detect hemolysis, what would you do? What would the lab majority do? So about 8% say the whole sample is rejected, and the majority of lab answer the same as us. They do report some tests and they reject some tests that are affected by hemolysis along with appropriate comments. And about 10 to 12% showing that they do release the test with general comments as well. And very minor of the lab saying that they release regardless of the result because they do not really care about hemolysis. So the last poll question, how do you use your percent hemolysis rate at your organization? Or percent cancellation due to hemolysis? So the answer is you do nothing since you do not collect any hemolysis data, or you provide information to physician or nurse where hemolysis occur, or you establish the quality improvement team between lab and the problem locations, or you really discuss with phlebotomists in terms of could be individual or the team, or the last one, you distribute data to corporate leadership. Wow, the information is very varied. Yeah, so it's very varied in various hospitals. So in this survey, it's also present an action throughout the year from each lab. And the 50% say they collect data, they distribute to leadership. Or also, they also discuss with hemolysis with phlebotomists. They also provide an ongoing training. And is it really successful? So 50% of the lab saying that they try to reduce, they see a slow progression, but still not successful. 50% they're still trying. 10% they're concerned, they still don't know what to do because hemolysis rate is still does not decrease. And 8% really say nothing helping, they still don't know what to do. And about 2.3% start to be giving up and really ignore hemolysis. So I hope we will not go to that. So let's go to the breakout session and have a discussion. Okay, so everybody back to the main room. Would you like to share the summary from your breakout session, moderator Davor?
Yes, you broke me in the middle of the sentence. I didn't realize the breakout was closing. Anyway, in our group, there are a few points were made. So we did talk a little bit about validating the age index on different platforms. So some labs do it, they even do it periodically. So this is about the H index validation itself. That's 0.5, really mean 0.5. And also about the quality control that may be used for hemolysis index. So some users have tried the Bio-Rad, but they seem not to be too happy with it. So it might not be the best way to go. And then we also talked about, there were some comments made about validating the cutoff for different tests. And so many users don't do it. It's a lot of work, and they simply take the manufacturer's values. But some users have found that these values, for example, from Roche, tend to be very conservative. So it may pay to relook at some of them, especially if your rate of rejection because of those manufacturers kind of actually go up. So if you can, you would validate in-house.
Okay, so my part, how does your lab record hemolysis result and report? So it very, very varied. And again, it does show that the practice are not really standardized. Some labs do report the H index from the instrument. Some lab report like 1+, 2+ as a grading. Some lab do not report H index, but didn't put the comment attached to the test result. So basically, it's very varied.
So our third breakout group, our question was, do you use percent hemolysis as one of the quality indicators at your organization? And then how do you calculate percent hemolysis? I think definitely there's variable approaches. Many don't use percent hemolysis per se as a quality indicator. Some labs don't actually reject any samples. Everything gets reported with a comment, and other labs they reject depending on the test, if that's impacted. So there's some variability in practice and how it's tracked. So for example, one comment was about monitoring hemolysis across multiple sites, is that it's not consistent throughout and it's difficult to benchmark it. So that would be, it wasn't deemed to be very useful. Another comment was that although they have basically a mixed approach, but they don't use specifically percent hemolysis, but they do monitor the number that's rejected. So they have a monthly report. And then there was one participant who tracks a percent hemolysis based on the LIS trigger that has this H index greater than 30. Interestingly, there's been some engagement of also nursing staff for quality improvement using this data. So I think that that was a great example of how it can be used to improve practices and highlight also the chance of using educational kind of approaches. And then the other comment was about that there's one lab that files safety or incident reports for each hemolyzed sample. So they use kind of the safety tracking system or the incident report tracking system to help track this. So I thought that was interesting as well.
Thank you, Lucia. Felix?
Yeah, so our fourth breakout group was about, have you ever done any type of quality improvement to improve hemolysis at your organization? So one of the participants did mention that they were able to start a QI where the big intervention was having lab phlebotomists help train inpatient nurses, and they did improve hemolysis a lot in the emergency department. One of the very useful tools to help that QI project was the software called Tableau, where they could identify the specific nurse who would be drawing the blood. That is something very new, and I've never seen that at our institution. But they said that that was very, very critical to being able to actually deal with hemolysis and improve it in the ED. When the participants spoke about this intervention, I did relate to my own experience here at Sinai, where, I tried to apply for some internal QI funding to improve hemolysis for a specific inpatient ward. forward by having our outpatient phlebotomist train. And it was very unfortunate because the feedback was that they see the value, but this is not innovative. And so there's something to be said about in trying to deal with hemolysis at your organization, you need buy-in, and the organization needs to see the value of some basic things to do to improve hemolysis. And unfortunately, it seems that here at Sinai, they see innovation and patient care as sometimes mutually exclusive things or basic things, right? They say it's not innovative, therefore we don't think it would add as much value, even though it is something that directly affects patient management here. So that's sort of the discussion that we had.
That's interesting. Thank you, Narun.
Hi. So in the last breakout room, we talked about whether or not site will consider comparing their hemolysis rate with other organization and why or why not. So some participants basically said this would be something that they would do. They would compare so long as they can compare apples to apples. Basically, they need to know the group that is collecting, whether it's a lab collect or it's a nurse collect, because that would make a difference. And also need to know the department. Which department, if you're comparing with your peers, what department are you comparing to? What location are you comparing to? Because not all locations will have same sort of hemolysis rate, so you need to look at the department and location level as well. One of the participants had mentioned basically years ago they had when they're looking at their rates, they are doing the hemolysis based on visual check, and depending on the experience of the techs, some would probably grade it differently than the other, and so they have now, based on that, their findings and experience, they have fully automated the hemolysis. So now they're doing it on the instrument. Look like there's definitely interest in participating, so long as it's kind of stratified and we can compare apples to apples.
That sounds good. Thank you, Narun. So for my last piece, I just want to share with you what we did at William Osler. We also shared the hemolysis data, and we are trying to come up to identify phlebotomy service and professional education as well. Here is just a scorecard comparing between the one who collect blood MLA. As you can see, the percent hemolysis rate is a lot lower than the non-MLA. However, this approach has been seen some challenge because there's a rapid change of staff. There are also a recent study sharing and showing that just a minimum change can make a big impact. So we talk about when you collect blood and not completely full draw, that will lead to % high hemolysis rate. So with the policy has changed to have blood collection more than 1 ml in the vacuum container, it does change and improve the turnaround times. From 90th percentile, turnaround time has been reduced. The same as hemolysis is also reduced. So just a minimum change can also make a big impact. At the end, as Narun said nicely, at the end, if we need to compare apple to apple, we should be consistency in terms of hemolysis detection, reporting, and how do we calculate percent hemolysis. And the benefit of participation in a peer group program, it is nicely said by Davor, and I like to encourage people, if you can participate, please do. The source of indices, it can be done, again, set up the same thing. The report can be done through the LIS, can be pulled by the middleware, and can also be pulled by the instrument. So in this case, if you would like to have the data, you might have to contact your vendor. And at the end, you can submit the data to SQBC like we do, and then we can have a peer comparison. So I'd like to end my talk and really thank you everyone for participating.
Thank you very much, Saranya. I know we are at the hour. If there's one burning question, I think we can entertain one question in the limited amount of time. But seeing that there are none, and I recognize that people do want to be able to move on to the next part of their day, I just want to conclude by, again, thanking all the speakers that we had today. We had excellent presentations, and a lot of interaction through our polling and breakout rooms. I do also want to thank our moderators and for their help in today's session. So for continuing education credits, I'm going to provide the code for today's session. It is in the chat box. And so for those of you who are CSCC members, you can follow the usual credit system. But for those of you who are not a part of CSCC, there is a link for you to enter your code. And that's in the QR code and also in the chat box. If you do have any trouble with this, just let me know, or Jenny, and we can follow up with you individually. We are very grateful again to our sponsor, the OSCC, for the financial support to obtain the continuing education credits. Okay, when you do the certificate, there is another link for a session evaluation, and I really do want to ask you to give your evaluation of the speakers and of our session as well, and your feedback will be evaluated. Later on in the upcoming weeks, we will do a survey for those of you who participated in person, and for those who have watched the recording online, to ask what the next steps and what future directions would you like to see from the Quality Indicators Working Group. So that completes today's workshop, and very grateful to all of you who could attend today. There is more information about the Quality Council. There's an opportunity for you to access our resources or become involved, and you can find that on the LMP website. So thank you again, and I wish everyone a good day.